Hello everyone. So here is one more video on problems of the linked list. So today's agenda is to find out the middle of the linked list. So without any delay, let's begin with the video. Okay. So our problem statement is find the middle of the linked list. So this is the simplest one solution. So here, like we will be traversing the list and finding out the length of the list, and then we will find the n by second node of the linked list, like if size is even, or n plus second plus 1 if size is odd. So let's just take an example. So here size of the linked list is 4, so that is even. So what will be middle? Middle will be n by 2. So first and second. So this will be the middle. So let's just say there was one more element. So in that case, size is 5 and size is in odd. So what our middle will be? N by 2 plus 1, as you can see here. So in that case, like our middle will be n by 2. So n by 5 by 2 is 2. So we will reach here plus 1. So that will be the middle if size is 5. So what will be the time complexity? Time complexity will be on just finding just just to find the length of the linked list, and then on again just to reach to the end of second node of the linked list. And space complexity is O1 because we are not using any extra space. So in the earlier solution, we were traversing the linked list 2 times. So we have to more optimize it. So we will be using now hash table. So in this technique, like we will be traversing the linked list once, and we will be preparing hash table of that. So as you can see here in the example, this is the list. So I have prepared the hash table of it, ABCD, as you can see here. And after preparing the hash table, like we will be easily able to find the size of the linked list by finding the size of the table. And then let's just say like this is the uh, 4 node uh, 4 node linked list, so its middle will be second. So we can easily find out the second element in the table in O1 complexity. And if there would have been 5 elements, then again middle would have been n by 2 plus 1. So we would have fetched the third element in O1 complexity. So time complexity for that solution will be On because we are traversing the list once and preparing the hash table out of it. And space complexity will be On because we are preparing an hash table of n elements. So in the earlier solution, our time complexity was On and space complexity was also N. So we have to more optimize it. So now we will be using two pointers approach to optimize it. In the two pointers approach, we will be keeping 2 pointers, and we will initiate both the pointers from the head of the linked list, and then we will move one of our pointer to 2 steps and another pointer by 1 step only. So let's say this is our fast pointer and this is our slow pointer. So we will be moving this pointer by 2 steps, 1, 2 at a time, and this pointer by 1 step only, 1. Then again we will move it 1, and as we will move by second step, it will reach to the null, and we will check this condition in the code, and our second pointer will be at the middle. So this is the like one thing. So let's just take another example of odd number of nodes. So in this case also, like we will be going with the 2 pointers approach. So here, like our fast pointer will move 2 steps, slow pointer will move 1 step, then again fast pointer will move 1 and 2 steps, and slow pointer will move 1 step, and again it's going to move one more step, and it will find it will reach to the null. So that is the end of the linked list. So we will return our slow pointer address. So this will be in the middle. So time complexity for this solution will be On because we are traversing the list only once, and space complexity will be O1 because we are not using any extra space in creating the hash table like in the earlier case. So it will be O1 only. So here is the code of the algo. So basically I am initializing two pointers, one is slow pointer, one is fast pointer to heads, and then like I am using this variable I. So I am while my I is 0, so I am incrementing fast pointer only, and then I am changing the value of the I, and when value of the I is 1, then I am incrementing both the pointers, slow pointer and fast pointer by one step. And here is the condition while fast pointer dot next is not equal to null. And at the end I am returning the slow pointer because it will be containing the middle position. So let's just run this code. Okay, so this is the linked list. So what our middle will be? Middle will be 3 because number of elements are even 1, 2, 3, 4, 5, 6. So middle will be 3. Let's just take an example of odd numbers. Okay, so these are the odd numbers 3 and 3. So 7 numbers total there in the linked list. So our middle will be at the fourth position. So here it has written 4. And also like I have written the base condition here. So thanks for watching.